What's up guys, and welcome to this tutorial on question 2 of the 2017 exam, the final exam. Let's get into the question. Okay, so a cyclist is riding north. Cyclist is riding north at 2 meters per second along a straight road. A velocity versus time graph of the motion of the cyclist is shown for 10 seconds. Basically, okay, so let's decode this graph. Okay, so we have a velocity time graph. Okay, so here we're going to take north as being positive and south as negative. So here we have a constant velocity. Here we have a constant velocity. Okay, here he's decelerating. Okay, so he's traveling at a constant velocity of 2, then he decelerates all the way to 0, then he starts moving south, and he's accelerating here. Then he goes at a constant velocity of -2, and then he's slowing down from -2 to 0, so he is decelerating once again. And we have a positive area here, so that would be traveling north. And we have a negative area here, which would be traveling south. Okay, so sometimes it's better to just understand what's actually happening in the graph before we even look at the question, because we've probably answered maybe most of, if not the entire question already. Okay, so question 2.1. So question 2.1 is a definition, which is nice 3 marks. So velocity is define velocity. Okay, so velocity is the rate of change of position. Okay, and with that definition we get ourselves 2 marks, which I'm always happy with. Okay, so during which time intervals is the cyclist constant velocity? So when is he traveling at a constant velocity? So question 2.2 we answered right in the beginning. Okay, a constant velocity, we can either give it in intervals of time, so 0 to, that would be, so this is constant velocities of 0 to 4 seconds, and then also from 7 to 8 seconds. Okay, and then also don't forget here we've got a constant velocity which would be 9 to 10 seconds. Okay, alternatively, both of these answers are correct. We could give the labels, the respective labels. In this case, 0 to 4 seconds is A to B, 7 to 8 seconds is D to E, and F to G. Okay, so any of those is correct. You only need to put one of them, and we get 3 marks, and a good giveaway is that it's worth 3 marks, so we probably need 3 time intervals. Okay, question 2.3, during which time intervals is the cyclist slowing down? Okay, so where is he slowing down? I've discussed this below already, a bit before. Basically, he's going from 2 to 0, so this time period right here, which would be from 3 to 5 seconds. Okay, and then also, so he gets to 0, then he turns around and starts increasing his speed, constant velocity, and decreasing, which is from 8 to 9 seconds. Okay, so I'm not going to go and do the letters, but you can if you want to. And then the last question, 2.4, during which time intervals is the cyclist traveling south? Okay, so when is he traveling south? So here he was traveling north. In this first region we said all of this is traveling north, so all of this is when he is traveling south, which we mentioned before as well. So that would be between 5 and 9 seconds. And again, I'm not going to give you the letters, but you can go do that. Okay, question 2.5 is a nice definition again. Okay, so define acceleration. Acceleration is the rate of change of velocity. Okay, and we get 2 marks for that. free marks there. And it says calculate the acceleration of the cyclist between 3 and 7 seconds. So question 2.6, between 3 and 7 seconds. Okay, let's clean up, or let's change colors between 3 and 7 seconds. Okay, so remember we've been given a velocity time graph. So to get the acceleration, we're looking at the gradient. So we're looking for the gradient. So the acceleration is equal to our gradient, which is the change in y over change in x. Okay, so let's choose this as being 0.1, this as being 0.2. So or b as being, basically we're choosing b and d. So change in y is 2 minus minus 2. So we have 2 minus minus 2 over change in x. So the x value here is 3. Okay, let's clean up. Okay, so the x value here is 3 minus, the x value here is 7. So we're looking at 3 minus 7. And the answer for our acceleration is 1 meter per second squared. Okay, so it comes out as 1 minus 1 meters per second squared. So that's equal to 1 meter per second squared and a direction of south. So the negative sign just indicates that we're traveling in southwards. That's given by the negative slope, as well as the fact that we chose upwards as being positive, or it was given to us actually. Okay, cool stuff. And then the last question, 2.7, says sketch a position time graph on a set of axes. Values are not required, but you must give the labels A to G. The cyclist position is 0 at t equals 0. Okay, so let me do this question above here. So let me try to link it up nicely. Okay, so we're looking at the position in meters versus time in seconds. Okay, and you guys do need to put these axes in. 0, 0, you need to put that in as well, and potentially even a heading such as position versus time graph for first 10 seconds or something like that. Okay, so we start at 0, 0. Okay, then he's got a constant velocity, so we have a nice straight line graph all the way till B. So this would be A, this point here would be B. Okay, from B, what we have is he starts slowing down, so we're going to have a gradient, nice change there. He's slowing down all the way till C. Okay, at C his position does not change, and then he's going all the way to D, so he's slowing down all the way until he gets to D. Let's continue with that. There we go, D. Let's say that's point D. At D we have a constant velocity once again, so we have a straight line graph. That should be straight. Let's see, something like that. That's straight. That's point E. Okay, from E what we have is he's slowing down once again, but quite steeply. So maybe we can do something like this. So as you can see, the gradient here is about double the gradient that it was here, so we have to slow down quite quickly. So it's going to look, let's say, something like that. Nice sharp gradient. Okay, and then he is not moving, so his position would not change, or the cyclist position would not change. That would be F, and that would be G. Okay, so I hope you guys were able to follow. Maybe I should have drawn it a bit differently. It looks about right. Maybe this needs to be a bit steeper here. But yeah, you guys get the idea. So what's happening here is we have a constant velocity, then the gradient, we've got a gradient here, so he is having a change in position, but his change in position is slowing down. Then he starts to increase, his change in position starts to increase in the opposite direction, because here he moves from going north. He was going north on the left hand side, on the right hand side he's going south, so we have to change the direction of this graph. So that's why we started, instead of this continuing like that, it started going downwards. And then we have a constant velocity once again, and a similar gradient to before, so the gradient on these two should be the same. Then we have a nice steep change in velocity, and then this last leg here, his velocity is 0, so the change in position, there cannot be a change in position. Okay, yeah, so if we wanted to, we could also just quite easily section this into, what's that, 1 there, 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 there. That would be 10, 9, 8. D would be 7. C would be 5 seconds. I'm just putting in the times. B would be 3 seconds. That's 0 seconds. And you can even section it out as you wish. 6, 4, and 2, 1. There we go. Okay, guys, and we get 21 marks for that. I think this video was relatively short. Don't think it took us 21 minutes to do it, which is good. And we get 6 marks for that. Okay, so cool, guys. Thanks for watching. I hope you found this useful. And in the next video, we will continue with question 3.